All right, here's example 2, where we're graphing the natural log. So to remember, that is a base of e. So just like the previous example, when we evaluate the function for -1 and 0, it's outside the domain because our domain has to be x greater than 0. So then we substitute 1 into the function and 2 into the function, and we just use our calculator, and we get 0 and 0.693. So as ordered pairs, it's 1, 0 and 2, 0.69. So when we graph this out, it'll look very similar to our previous example. We have the order pair 1, 0 there. The asymptote is in the same spot as our base 10 common log, and that asymptote is at x equals 0. It's a vertical asymptote. The range of values is the same. It's going to be all real numbers for all logarithms. Example 3, graph each of the logarithms and find the asymptote and then describe it. So if we look back at this chart, these are the transformation rules for our logarithms. So this first example is the child function, and we want to describe the two transformations that exist. So the first transformation, I'm just going to write the parent function y equals the natural log of x. The first change is we have a negative in front of the function. So what that does is it reflects it across the x-axis. The second transformation is a -4 inside the function, and what that does, it moves it right 4 units. So notice where the asymptote now has moved. In the parent, it's right here, and now it's moved to the right 4 units. So now here is our new asymptote. And then here's our child now graphed out. So in our lesson, we're focusing more on just the description. The second example, here is our child, and the parent is a base 10 logarithm. The first transformation is a multiplier in front of the function. So what that does, it has a vertical stretch by a factor of 3. The second transformation is a +5 at the end of the function, outside the function. So what that does is it moves it up 5 units. So with this one, the asymptote has not moved at all because we didn't go left or right, so it's still in its same position. And then you can see here, this is our parent function right here, and then we have our child right there, graphed out. Given this function, so now we have a child, and we want to describe it, graph it, and identify the domain and range. So who is the parent function? The parent function is y equals the natural log of x. So that's a function we graphed earlier. It looks like this. So there's our parent function. Just a quick sketch of it. Now we have some transformations, the child. We have a negative in front of the function. So what that does, it reflects it across the x-axis. So here's our x-axis right here. and it's going to reflect it. The next transformation is inside the function. It's plus 1, so we think opposite. That's going to move it left 1 unit. So now our asymptote is moved left 1. The last thing that's happening is the minus 2 at the very end. What that does is it moves the graph down 2 units. So what does this graph look like? I'm going to do this in purple. When it's done, it's reflecting, it's moving left 1, and then down 2 units. The domain is everything to the right of that vertical asymptote, so x greater than -1, and the range of values is always all real numbers for a logarithm. Here's another example. The parent is our common log, y equals log of base 10. Here's a quick sketch of it. There are 2 transformations. The first one is a minus 3. So that's going to move the asymptote to the right 3 and the function to the right 3. Then we have a plus 4, and that plus 4 is outside the function, so it's going to move it up 4. So the child will look like this. And again, we're just doing a quick sketch of it. The domain is everything to the right of that green asymptote, and then the range is all real numbers. Okay, example 6. Now we're going to give you a parent function and some transformations, and we want you to write the function. So here's our parent, f of x equals the natural log of x. The first transformation is we want to vertically compress it by a factor of 1/2. So what happens is that's going to be a multiplier in front of the function. So we have 1/2 and then the natural log of x. The second transformation is we're going to move it to the left 3 units. So that happens inside the function. So I'm going to erase that parenthesis there. And we always say think opposite when we move left and right. So that's going to be, if it's left 3, we're going to do a plus 3. Our second logarithm is our common log, base 10. We have a vertical stretch by a factor of 2. So that's going to happen in front of the function. That's our multiplier. The next transformation is 3 units to the right. That happens in front of the function, or I'm sorry, inside the function. So we say think opposite. It's going to be minus 3. And our last one is a reflection across the x-axis. So when we reflect across the x-axis, we're going to have a negative in front of that 2.